आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. So the question is, in Millikan's oil drop experiment, what is the terminal speed of a drop of radius r equals to 2 into 10 to the power 5 meter. Density is 1.2 into 10 to the power 3 meter cube. Take the viscosity of air at the temperature of the experimental to be 1.8 into 10 to the power minus 5 Newton meter square. How much is the viscous force on the drop of that speed? Neglect buoyancy of the drop due to air. So basically we have to calculate two things. First is the speed of the drop, terminal speed of the drop, and second is the viscous force. Now we know that suppose this is the drop which is moving downward direction with the speed of v. Now the other particles of the liquid is applied the force in the opposite direction of the motion, and that force is known as viscous force, that is Fs. When this Fs is balanced by the weight of this drop, and that time when Fs equals to, when Fs, that is the viscous force, is equals to Fmg, at that time this velocity is remain constant, and that constant velocity is known as the terminal velocity or the terminal speed of that drop. And there is a direct formula for terminal velocity, that is given by Vt, terminal velocity, that is equals to 2r square g rho minus sigma upon 9 neta, where r is the radius, g is the acceleration due to gravity, rho is the density of ball, this is density of ball, and sigma is the density of medium. Okay, this is the density of medium, and eta is the viscosity. So putting all the values in this formula, so I will have Vt, that is equals to 2 into r is given as 2 into 10 to the power 5 meter square into g is 9.8. Rho of volume, density of volume, is given as 1.2 into 10 to the power 3 minus rho of medium is 0 upon 9. Viscosity is given as 1.8 into 10 to the power minus 5. After simplifying this, the terminal speed of drop is coming out to be 5.8 into 10 to the power minus 2 meter per second, and I can also write this as 5.8 centimeter per second. Okay, so this is the terminal velocity. Now in second part we have to calculate the viscous force, and the formula of viscous force is given by, that is Fs, viscous force, that is equals to 6 pi eta r v. You all know all the terms. Eta is the viscosity, r is the radius, v is the terminal velocity. Okay, so putting the value, 6 into pi is 22/7, eta is given as 1.8 into 10 to the power minus 5 into radius is given as 2 into 10 to the power 5 meter, and V terminal we already calculated 5.8 into 10 to the power minus 2 meter per second. So finally the viscous force after simplifying this is coming out to be 3.93 into 10 to the power minus 10 Newton. So this is the answer of viscous force. Okay, thank you.
क्लास 6 से 12 से लेके नीट, IIT, जेईई मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।